Do you know what is the most useful type of motion in physics? It is constant acceleration. In this lesson, you will learn about constant acceleration. What is constant acceleration? Constant acceleration is the change of the state of motion of an object by changing its speed, its direction of motion, or both. Any of these changes is a change in velocity. The rate at which the velocity is changing is called acceleration. Because acceleration is a rate, it is a measure of how the velocity is changing with respect on time. Constant acceleration is a special case of acceleration. Whenever an accelerating object will change its velocity by the same amount each second. For example, a car is traveling with a speed of 2 meters per second in the first second and 4 meters per second in the next second. Then the velocity changes in 2 meters per second every second. Therefore, the acceleration of the car is 2 meters per second squared. For better understanding, here's an example. But first, take note of the formula. Vf equals to Vi plus At. X equals to Vit plus At squared over 2. Vf squared equals to Vi plus 2Ax. Vf stands for final velocity, while Vi is equal to initial velocity, x is equal to distance, t is equal to time, and a is equal to acceleration. Let's start. On a dry road, a car with good tires may be able to brake with a constant acceleration of 4.92 meters per second squared. How long does a car initially traveling at 24.6 meters per second take to stop? And how far does it travel in this time?
Using the equation Vf is equal to Vi plus At, we will be able to find how long does a car take to stop. Substituting the given values, we get that 0, because the car will eventually stop, is equal to 24.6 meters per second plus negative 4.92 meters per second squared, because it decelerates, the acceleration is negative, multiplied by time. Solving for time, we get that time is equal to 5 seconds. Another application of constant acceleration is free fall. Imagine this. An apple falls from a tree. Does it accelerate while falling? We know it starts from rest position and gains speed as it falls. This gain in speed indicates that the apple does accelerate as it falls. Gravity causes the apple to accelerate downward once it begins falling. In general, air resistance affects the acceleration of a falling object. Let's imagine there is no air resistance and that gravity is the only thing affecting the falling object. For free-falling bodies, we use these equations. This is just a variation of those first equations wherein g is equal to 9.8 meters per second squared. Here's an example. You are on top of a building which is 50 meters high and about to throw up a ball with an initial speed of 5 meters per second. Find the maximum height that the ball can attain, the time to achieve maximum height, the time from top to the ground, the velocity just before touching the ground. Using the third equation and 9.8 meters per second squared for g, we find that the maximum height that the ball can attain by plugging in the values. Using the equation Vf is equal to Vi minus Gt, we find time is equal to 0.51 seconds. To find the time from the rooftop to the ground, we use the second equation. We find that time is equal to 2.3 seconds. To find the velocity just before touching the ground, we use the third equation. We find that the final velocity is equal to 17.2 meters per second.
Created using Powtoon.